Now we will do the short question answer of chapter number 2, vectors and equilibrium, which are 4, 5, 6, 7, 8, 9, 10 in the reduced syllabus. So question number 4 is, can a scalar product of two vectors be negative? Provide a proof and give an example. So let's start. Yes, scalar product of two vectors can be negative when they are in anti-parallel direction. They are present in anti-parallel direction, making 180 degree. So we have to prove it and give example. Proof. How can we prove it? We can prove it by A dot B is equal to AB cos theta. So this is the vector A and this is a vector B. They are having angle 180 degree. Linear form is 180 degree. So A dot B scalar product is AB cos 180 degree, and cos 180 degree is -1, so it would be minus AB. So A dot B is equal to minus AB. Now we have to give example. In the case of friction, work done is equal to force dot displacement. So cos theta when displacement is in this direction and force is in opposite direction, so making angle 180 degree. FD cos 180 degree is equal to minus FD. So we prove by the example also. Now question number 5. Answer. Question 5, a statement is given. A and B are the two non-zero vectors. How can their scalar product be zero, and how can their vector product be zero? Non-zero, they are not zero, so scalar product can be zero. Scalar product, and we have to find the vector product. How it is zero? So scalar product is 0 when the two vectors are perpendicular to each other, making angle 90 degree, because cos 90 is 0. Cos 90 is 0. See, cos 90 is 0. Perpendicular, making angle 90 degree. Like I will make a diagram. This B vector is in this direction and A vector is moving up. So if you pick up a basket and move in the forward direction, this is the example of scalar quantity, scalar product when it is 0. So AB cos theta is AB cos 90 degree, and cos 90 degree is 0, so AB is 0. Okay, and vector product is 0 when they are parallel to each other, making angle 0 degree. Parallel to each other, theta is 0 degree. Like if the object is moving, if A vector is moving in this direction, then B is also moving in this direction. So here angle is 0 degree. So A cross B product is equal to AB sine theta, and sine 0 is 0. AB sine 0 degree. So A cross B is equal to 0. Question number 6. Answer. You can write it in the proper wording form. I just write in the short form. Question number 6 is, suppose you are given with a known non-zero vector A. The scalar product of vector A with unknown vector B is 0. Likewise, the vector product of A with B is 0. What would you conclude about B? So we are given with A is non-zero, means it is not 0. Of A and B is 0. Scalar product is 0 and the vector product is also 0. We have to find B. What is B? B is 0 or non-zero. So AB, if we take the scalar product AB cos theta, if suppose A is 1, if we take B as 1, then it will be AB. So we have to take the B 0 to become the whole equation 0. So it would be, if we put here 0, it would be cos theta is equal to 0. So B is, now if we take the cross product AB sine theta, then put here B as 0 sine theta, so it would be 0. Then the equation would be satisfied for us. So B is 0. Now question number 7 is, to open a door that has the handle on the right and the hinges. Oh, I am reading question number 8. Now question number 7 is, why a particular experience only one force cannot be in equilibrium. Now question number 7. For complete equilibrium, the both equations or conditions of equilibrium must be satisfied. Condition of equilibrium must be satisfied like first and second. Summation of all forces must be equal to 0 and summation of all torque must be equal to 0. But in single force, summation of all the force is not equal to 0 and summation of all the torque is not equal to 0. So it is not in equilibrium. Question number 8 is very interesting question, so I would not read it. You can see it from here. I will just explain you all. In this question, he has asked us about when you open the door, when you open the door, in which direction does the door open, anti-clockwise or clockwise? First I will write the answer, then I will show you practically. First I will write the answer. Torque depends whether the door opens. Torque produced in a door depends upon whether the door opens towards or away from you. Towards or away from you. अच्छा, कोशिश करती हूँ एक डोर बनाने की जो कि बन जाए तो अच्छी बात है. जब डोर खुलता है तो ये ऐसे अब हमारी तरफ खिंचता है. When door opens, that opens towards you, when door opens towards you तो कौन सा मोशन होता है, कौन सा डायरेक्शन होता है, मूव करके यहाँ से, तो ये टूवर्ड्स यू इट इज़ क्लॉकवाइज डायरेक्शन. और व्हेन जब अवे फ्रॉम यू, जब बंद कर रहे होते हैं तो ये अवे फ्रॉम अस होता है, तो ये एंटी क्लॉकवाइज होता है, यूँ करके, और ये यूँ करके होता है. यानी इस डायरेक्शन में मूव कर रहा था, और ये अंदर की तरफ इधर से एंटी क्लॉकवाइज. व्हेन अवे फ्रॉम यू, व्हेन द डोर opens away from you, anti-clockwise direction, anti-clockwise direction. Answer of question number 9 is winch. First we have to define winch. Is this to apply specific torque to fasten the nut or bolt. Okay, now torque is given by torque is given by torque is a cross product of position vector and force. Torque depends upon momentum. They are vector quantities. Torque depends upon moment arm, large wrench can cause large moment arm, or large wrench can cause large moment arm, and large moment arm can cause large torque, which can slip the nut and never fasten it. Question number 10 is the central force is one that is always directed towards the same point. Can the central force give rise to the torque about that point? So answer would be a central force is along a line joining the center of two bodies or points. For example, gravitational force is always acting towards the center of circle of center of mass and center of mass of satellite. So moment arm is 0. Arm is 0. So the torque produced in gravitational field is therefore hence torque produced in gravitational field is 0. So torque is equal to RFG sine theta if position vector is 0, moment arm is 0, so whole equation would be 0. So torque is equal to 0. So these were the questions short question answer of unit number 2, vectors and equilibrium. Thanks for watching. Allah Hafiz.